Okay, we'll start. Let them join. The unit number 4, that is section number 2. Section 2 is section 1 we have completed, and section 2 remaining 3 units. In section 2, unit number 4 is Earth Station. Earth Station, that is present both at the uplink and both in the downlink. Okay, Earth Station is present at the uplink also, and Earth Station is present at the downlink. This is the basic. In this Earth Station, what are the requirements are required for a particular and to receive the signal from the satellite. So he has mentioned the unit as Earth Station. In this Earth Station, whatever the parameters, what are the different types of Earth stations, and what is the frequency bands are using in this Earth Station, and what is the architecture of Earth Station, and how it is going to test a particular Earth Station, and what is the RF equipment is using in the Earth Station. Everything will be done through Earth Station itself. So whatever the functions, whatever the parameters are going to select in the Earth Station itself, based on that Earth Station, the satellite is going to work. Based on that Earth Station, the satellite will work, because you have seen in the unit number 2, a satellite subsystems. In that satellite subsystem, whatever all the components, whatever all the parameters are going to choose, and because of only the Earth Station. The Earth Station is the main component. In this Earth Station, they are going to install, they are going to integrate, and they are going to choose a particular equipment. They are going to choose one of the system which is working properly or not in a good condition to work. Everything will be selected based on this Earth Station, and after this, once the finalized, it has to be integrated in a particular satellite. After that, integration has done, and that is going to launch the satellite from Earth Station. The satellite should be launched from Earth Station to the Earth Station to the space. That is to revolve around the Earth, Moon, or the Sun. So Earth Station is very, very important for the consideration for the satellite system. This is what a basic definition of Earth Station. In this Earth Station, what we require? We require the parameters, what they are going to select, and in this parameter, you have to calculate a particular EIRP, that is effective isotopic radiated power. This is very important. EIRP, that is a received power, that is PR, and GR, that is PT into GT, that is transmitted power and the transmitted gain, that is EIRP. So this is important for the Earth Station. In this Earth Station, they are going to calculate a respective G by T ratio, a respective G by T ratio, that is gain to transmission ratio. You have seen in the previous lecture, that is previous unit in section 1, that is unit number 3. The G by T ratio, that is carrier to noise ratio, is directly proportional to the G by T ratio, or G by T is directly proportional to the carrier to noise. What is carrier? To carry the signal. To carry the signal. Whatever you are carrying the signal, in that signal, how much is the percent of noise should be present in that particular signal. So always the carrier to noise ratio is directly proportional to the G by T, that is gate to transmission. Okay, this is unit number 4, Earth Station. In section 2, he has mentioned unit number Earth Station, which are the contents present in that Earth Station. That is, first is the introduction. I have explained about the introduction of Earth Station. Next is the types of Earth Station. Types of Earth Station. Which are the Earth Station types? You have to remember this. He will ask you the question for 4 bars. Explain the types of Earth Station. Explain the types of Earth Stations. One is Fixed Satellite Service, FSS. FSS. Fixed Satellite Service. FSS is Fixed Satellite Service. Second, BSS, broadcast satellite service, broadcast satellite service. And third service is mobile satellite service. What is this types of earth station? What is fixed satellite service? Whatever the components we are using, that is fixed. It is not a movable. In the olden days, you are using a TV cable. You are using a TV cable with the antenna at the top of your house. That is fixed. That is fixed. It is not movable. It is not movable. In the previous days, in the olden days, in the last 5 to 6 years back or 10 years back, we are using TV cables. That is to be mounted at the top of your home. That is a fixed antenna. That is called as fixed satellite service. Whatever the signal is receiving, that is to the cable operator, and the cable operator is going to send that picture or images, whatever you are watching through TV, that's to your television. This is a fixed satellite service. Now, you are using a broadcast satellite service. That is receive only antenna or transmit only antenna. Receive only antenna, or it has to receive or it has to transmit. These are the 2 points comes under this. That is broadcast satellite service, that is your TV. Nowadays you are using the small antenna, that is Tata Sky, DTH, whatever it is, that is your broadcast satellite service. That has to be, you are getting the signal directly from the satellite. If there is a variation in the weather conditions, if once the rain has started, you will get one message that the signal is lost due to weather condition. A signal is lost due to weather condition. That is because you are implemented, you are integrated the broadcast satellite service. So if there is a problem in the weather conditions, a satellite is unable to give the signal to your a particular antenna. If the weather is clear, then you will get the clear picture in your television. That is broadcast satellite service. And mobile satellite service. You are using your smartphones nowadays. That is mobile satellite service. And whatever the signal you are receiving, that is only because of your satellite. You are using GPS at your car. Whenever you are traveling, that is you are using GPS. If you want to search any location, in your mobile, that is required the mobile satellite service. So this is what the types of earth station, that is fixed satellite service, broadcast satellite service, and mobile satellite service. This is the simple explanation. Next content is signal frequency station. What is single frequency station? A single frequency station is nothing but you have to transmit the signal or to receive the signal. Only 2 points are there in this. Single frequency station. You have to transmit the signal or to receive the signal. In this, the frequency station, we are using a high frequency band, very high frequency band, ultra high frequency band. That is single frequency stations. And some of the frequency band we have seen previously, that is C band, Ku band, and Ka band. What is the frequency band for C band? That is 6 by 4. 6 is your uplink frequency and 4 is your downlink frequency. That is C band. Now what is the Ku band? That is from 14 divided by 12. That is 14 is your uplink and 12 is your downlink. And Ka band, that is near about 34 divided by 20, I think. That is uplink frequency and the downlink frequency. And similarly for that, these frequency bands, we are going to use a bandwidth. A particular bandwidth will be allocated to the single frequency band. That is C band frequency is of 36 megahertz. 36 megahertz. See, the frequency will be measured in gigahertz or hertz, gigahertz or hertz, and the bandwidth is in megahertz. Bandwidth is in megahertz. The sub-C band, the bandwidth is of 36 megahertz. For Ku band, the bandwidth is of 56 megahertz, and for Ka band, the bandwidth is of 72 megahertz. These are what the frequency bands are used in a particular system for using the satellite. This is single frequency station. And next, a gateway station. What is gateway? We are communication has to be done from one country to the other country, that is terrestrial networks. That is from terrestrial networks. And you are going from one state to other state, you are getting roaming. If you change the states, you are getting the roaming. That is because of your gateway station. You have crossed state to state, and you have crossed country to country. I think you have yesterday have seen a live session of Facebook live session of Vishal Gaikwad. That live session is mainly only because of this gateway station. He is in Brazil. You are watching from Pandharpur, and he is in Brazil. So this communication has done only because of satellite through gateway. That is, yesterday you have seen, that is Vishwanath Gaikwad, I think. Next, what is Earth Station architecture? What is the actual design of Earth Station they are mentioning? In that Earth Station architecture, we require baseband signal. Baseband signal is any without modulation. In that Earth Station, baseband signal is one block. One is modulator. The next modulator is to encoder, and that encoder is received to the high power amplifier or high power noise, low noise amplifier, that comes to the decoder. Decoder will reach to the demodulator, and demodulator will receive the again original signal. This is what a real picture of Earth Station architecture, design consideration of Earth Station architecture. And next, Earth Station design consideration. In this Earth Station design consideration, they are going to use for designing, they are going to use some of the performance parameters. Which are the performance parameters? I have explained in the performance parameters as EIRP. One is effective isotropic radiated power. Next, it requires a particular gain, that is G, and it requires an aperture antenna, and it requires a total received power at the receiver end, and it requires a C by N, that is carrier to noise ratio, and it requires a G by T, gain to transmission ratio, and it requires signal to interference ratio, and it requires signal to noise ratio, that is SNR. These are the performance parameters present in a particular Earth Station. Optimization is there. Next, you have to test a particular Earth Station at the Earth Station itself. Earth Station testing is nothing but what? Whatever the equipment you are using while designing the particular satellite, and those equipments or those subsystems are working in good condition or not. If some of the systems or some of the equipments are not working up to the end of the satellite's life, so they will not consider such type of equipments. The equipments will be supportive. They are going to install one or two equipments. If one equipment is fed, and they will operate for other equipment, that is supportive equipment, so that we are get a signal from satellite. So whatever the equipment they are going to install in a particular satellite, they are tested at the Earth Station itself. They are tested at the Earth station itself. Okay. Next, the radio frequency equipment for Earth station. Radio frequency equipment for Earth station. What is the equipment of RF? Radio frequency is required. The frequency must be required for the Earth station equipment. This is what the clear idea about Earth station. That is all the contents clear idea about Earth station. And we'll see one by one. What is an Earth station? Introduction. An Earth station is a terrestrial terminal mainly located on the Earth's surface. It is a terrestrial. It is mainly located on the Earth itself, at the ground itself. Okay. Three essential elements of any satellite communication network or system include the Earth segment, that is a system subsystem. Here it is, you have seen in unit number 2, satellite subsystem. Include the Earth segment, the space segment. Whatever the Earth segment is nothing but you are going to choose a particular at the Earth itself. Whenever you launch a particular satellite at the space, and whatever the equipments are going to support the particular satellite, that is what the space segment. Next, and the up or down link between the space segment and the Earth segment. So this is very important. We are using two links. One is uplink, one is downlink. Uplink is from Earth station to satellite, that is from SIB. And downlink is from satellite to Earth station. So these two links are related with Earth station to the satellite and from satellite to the Earth station. This is what the concept of Earth station. Earth station design is mainly governed by the type of services. Once they have finally chosen the particular Earth station, after that Earth station, once you launch a particular satellite in a particular area, in a particular orbit, one satellite has been launched, what are all the services it is going to provide? That is very important. Just launching the satellite is not important. After launching the satellite, how much area it is going to cover and what are the services it is going to provide to the particular from satellite to the Earth station, that is important. What are the services it is provided? That is, we have seen this, we have explained, that is by the type of service to be provided, such as fixed satellite service, that is FSS, broadcast satellite service, that is BSS, and mobile satellite service, that is MSS. These are the three services or number of services are there. That is, one is maritime mobile services. When the ship is going on the sea, you are going to see a particular ship where exactly it is located. That is only because of maritime. Military services. Military is nothing but nowadays we are seeing that is China is going to where it is where they are located particularly. That is only because of your satellite. That is exact location can be fetched through the satellite itself. And the quality of service to be provided mainly dictated by the Earth station, that is G by T, that is gain and transmission. And the type of communication requirements such as telephone. Which are the communication requirements? You are using your mobile phones, the data, whatever you are going to use, sending the particular data, and the television, you are watching the television, what is going on nowadays in India, in the whole country. That is a type of communication requirements. That is, one is telephone, one is data, one is television. And international regulations. What is actually going on other than our country? That is international regulations. Cost consideration is also one of the important for while designing the satellite and while choosing the particular Earth station. Earth station, the cost and budget is very high. Earth station budget is very high. And site constraints. They are using some number of sites and different locations. That is also one of the consideration comes under this Earth station. The earth station is characterized by frequency bands. This frequency band we have already seen in the previous units also, that is 6 by 4 gigahertz for C band and 14 by 12 gigahertz for Ku band. These are some of the frequency band he has given for the example as a frequency band can be used in a particular satellite. And there is a polarization, linear or circular. That is, linear is nothing but that is a straight line. A circular, that is in circular. When it is a satellite is revolving around the earth, should be in a linear or in the circular orbit. Antenna diameter, you have to consider the antenna diameter. And I have explained you, that is, I have told you that the effective isotropic radiative power, this is one of the important parameters, one of the important performance parameters comes under this effective isotropic radiative power. G by T, gain to transmission ratio. Receive antenna gain, how much is the gain, how much is the gain we have received at the receiver. Modulation types, FM, AM and PM. Amplitude modulation, frequency modulation and phase modulation. These are the different modulation types. Access methods. Access methods we have seen the FDMA, that is frequency division multiple access, time division multiple access, etc. Nowadays we are accessing only because of this time division TDMA and CDMA. Exact timing with this code we are accessing the network, that is access method, FDMA, TDMA, CDMA, etc. and so on. This is what the introduction of the Earth station. Earth station, this is what one diagram, how it is exactly located at the Earth station. And the below is your Earth, and in the Earth there are number of antennas at the Earth station. And after that you are launching the satellite at the space, number of satellites are there. These are the two examples of Earth station, and the Earth station there are number of satellite antennas are present, and the satellite is going to provide particular signal to the Earth station. Similar example. Okay, we'll see first one and we'll stop here. The fixed satellite service. In this fixed satellite service is a type of mobile telephone service. Fixed satellite service is a type of mobile telephone service that allows users in a specific area. Whenever you are present in a particular area, that is to be allowed to access the network and make and receive cell phone calls. If you are located in a particular area and that area is located to you, based on that you have to receive the call and make a call if the network is available. Fixed satellite service systems or cell phone towers are placed in strategic or fixed locations and provide services to thousands of individual users simultaneously. We have seen in mobile communication, that is base station, base station transmitter. Base station, that is nothing but your fixed location. At that fixed location, you are going to access the particular network. And generally, fixed satellite service systems provide reception for several square miles around them. Whatever the network you are accessing, that network is available near about several square miles. If you cross that border, you have to connect to the other base station, that is other fixed satellite service. If you once you cross that border, you will connect to the other fixed satellite service, that is our base station. This allows users to communicate with multiple FSS systems as they travel without losing the reception. This means what? Whenever you are moving, your call will not be detected, disconnected. After that, that one base station is connected to the other is connected to the other, one and more. So more number of base stations are connected. After connecting this, you are not losing any call. So that means that is fixed satellite service. Okay. Okay, we'll stop here. I have a meeting, important meeting now. I got to call. Okay, tomorrow I will continue. Tomorrow no. Tomorrow I will take a tutorial. Please be ready with your seminars for 5 to 10 minutes. And Monday I will take class test 3. Be ready. On Monday I will take class test 3. And I will Tuesday will continue with this unit number 4. Tomorrow I will not explain anything. You have to explain it based on remaining last 3 units. Okay? Your attendance first. So be ready for tomorrow. Submit your synopsis by tomorrow. Submit your exam forms. Otherwise, your result will not be declared. Keep in mind. On Monday, we'll take the test.